Assalamu alaikum. I'm Rida Khushid, ID 1810168 I will be explaining word classes. Parts of speech has two broad categories: open class and closed class. Closed classes, like prepositions, have a relatively fixed membership. The term function words are typically closed class words like of, it, and, or, you, that are short, commonly used, and have structural functions in grammar. Nouns, verbs, adjectives, adverbs are considered to be four major open classes. Nouns are words that refer to person, places, or things. Common noun are words used to name general items rather than specific ones. Common nouns are divided into mass noun and count noun. We also have proper noun. Now, about verbs, it refers to actions and process. We have auxiliary verbs. Auxiliary verbs includes copula verbs and modal verbs. We have adjectives and adverbs. Adverbs, we have locative or directional adverb, which specify the direction or location of some action. We have degree adverb, we have manner adverb, and we have temporal adverb, which describes the degree of the action, manner of the action, and the time that the action took place. Now, determiners like this and that can mark the start of an noun phrase. Articles are also part of determiner. Then we have interjection. And we have prepositions. Preposition is word class in word classes contains particles and phrasal verb. We have conjunction that join two phrases, classes, or sentences. Subordinating conjunctions like that which link a verb to its argument are complementizers. We have pronouns like wh pronouns like what, who, whom, whoever. Now we will talk about parts of speech tagging. Um, Parts of speech tagging includes ambiguation tags, that is, words that are ambiguous, that have more than one possible parts of speech, and the goal is to find the correct tag for the situation. The goal of parts of speech tagging is to resolve the ambiguities and choosing the proper tag for the context, and the accuracy of parts of speech tagging is very high. Now we will talk about the HMM, part of speech tagging. The HMM is a classic model that introduced many of the essential sequence modeling elements that we will encounter again in more current models. A Markov chain model that explains the probability of sequence random variables or states, each of which may take on values from a range of possibilities. When predicting the future, Markov model incorporates the Markov assumption on the probabilities of this sentence that the past doesn't matter, just the present. A hidden Markov model enables us to discuss both seen events and hidden events that we consider causative components in our probabilistic model. The components of HMM tagger is probability A and probability B. The challenge of obtaining the hidden variable sequence matching to the series of observation in an HMM with hidden variables decoding is what's it called. Thank you. That
Assalamu
was.
alaikum. My name is Zarin Tasneem Prami. My ID is 1810158 I'll be discussing conditional random fields. It is a field that is class of discriminative model best suited to prediction task where contextual information of the state of the neighbors affect the current prediction. In parts of speech tagging, as in other tasks, we often run into unknown words, proper names, and unknown words are created very often, and even new common nouns and verbs enter the language at a surprising rate. In the linear chain, the version of the conditional random field are most commonly used for language processing, and the constraint only depend on the current and previous output token that would categorize a linear chain. In the linear chain, each local feature can depend on any information that can take on the value of 0 or 1, and explicitly a notation is used to mean 1 as true and 0 otherwise. The idea of what features to use is done by the system designer by hand. The specific feature are automatically populated by using feature template. This template automatically populate the set of features from very instant in the training and test set. It's also important to have feature that help in unknown words. One of the word shape most important is the word shape feature, which represent the abstract letter pattern of the word by mapping lowercase letters to uppercase, to numbers, to retaining punctuation. One feature that is especially useful for location is a Gaster, a list of place names often providing millions of entries for locations with detailed geographical and political information. This can be implemented as a binary feature indicating a phrase appears in the list. Concretely, this involves a filling n into t array with the appropriate values, maintaining back pointers as we proceed. As with the hidden Markov model, when the table is filled, we simply follow pointers back from the maximum value in the final column to retrieve the desired set of levels. Um, Now, the parts of speech taggers are evaluated by the standard metric of accuracy. The named entity recognizer are evaluated by the recall precision F1 major. Recall that recall is the ratio of the number of correctly labeled responses to the total that should be um, labeled. Precision is the ratio of the number of correctly labeled responses to the total labeled, and F major is the harmonic mean of the two. Now, in the details section, a rule-based method was proposed to improve the recognition accuracy on read aloud performances using a set of linguistic rules learned from a collection of transcriptions of other passages being read aloud. The morphologically rich languages are used in the NLP literature to refer to languages in which substantial grammatical information, that is, the information concerning the arrangement of words into syntactic units or cues to syntactic relations is expressed at word level. So, thank you so much. This is all from my side.
Hello, I'm Fatih Nishad, BNID 213011716. This chapter includes named entity and named entity tagging. A named entity is anything that can refer to a proper name, such as a person, a location, or an organization. The task of the name entity recognition is to find span of text that constitute proper name and tag the type of the entity. The name entity consists of this property. So, four entity tags are most common: person, location, organization, or geopolitical location. The term name entity is commonly extended to include things that are entities for including dates, time, and kind of temporal expression, and even numerical expression like prices. For example, citing high fuel price, United Airlines said Friday it has increased fares by $6 per round trip. Here, the United Airlines is the organization, Friday is time, and $6 is money tagged by this process. Named entity tagging is a useful first step in a lot of natural language processing tasks. In semantic analysis, we might want to know a consumer sentiment toward a particular entity. Entities are useful first stage in question answering or linking text to the information in structured knowledge source. Like Wikipedia, and named entity tagging is also central to tasks involving buildings, semantics, representation, like extracting event and relationship between participants. This part also includes bio, the standard approach to sequence leveling for a span recognition problem. This is a method that allows us to treat NER like a word-by-word sequence leveling task by via tags that capture both the boundary and the name entity type. For example, Jane Villeneuve of United, a unit of United Airlines holding state fare applies of the Chicago route. Here, Jane is a person tagged, and United is the organization. United Airlines holding is an organization, and Chicago is a location. This example shows that biotagging, as well as variant called IO tagging or BIOS tagging. In biotagging, we label any token that begins or a span of interest with the level of P. Token that occur inside the span are tagged with I, and any token outside of any span of interest are level 0. Level O, sorry. While there is only one O tag, we will have distinct B and I tags for each named entity class. The name of tag is thus 2n plus 1, where n is the number of entity type. Biotagging can represent exactly the same information as the bracketed notation, but has the advantage that we can represent the task in the same way, simple sequence modeling, as part of speech tagging. So, sequence leveling of part of speech and named entity chapter includes the Viterbi algorithm. Here, the Viterbi algorithm is the decoding algorithm for hidden Markov model. It consists of dynamic programming and the minimum edit distance. The algorithm illustrates that it takes the observation of length t and state graph of length n, takes the parameter and returns the base path and path pro. First of all, create a path probability matrix named theta b equals n and t for each state of s from 1 to n. Do initialization steps, and the initializations will be theta b s1 such that pi into bs. Back pointers is rs1 is equal to 0 for each time step t from t to 2 to t. Do the recursion steps for each state s from 1 to n. Do theta b maximum of s and t, and in theta b s prime t minus 1 into as prime s and multiplied by bs ot. Back pointer is taking argmax of theta b multiplied by as and b. Base path is max of theta b, and base pointer is argmax of theta b t. The Viterbi algorithm first sets up the probability matrix or lattice, which with one column for each observation O1 and one row for each state in the graph in the state graph. Each column thus has the cell of for each state Qi in the single combined automation. Thank you. That's all from this chapter.